Give this worksheet, this is the 4.3 Practice B worksheet. A little bit of trouble getting this one set up for some reason. Best thing to do with these triangles is draw generic triangles and use that as a graphic organizer to see what angles they're talking about. So MT and TA have angle T between them. Draw another triangle for CDA that gives us angle C between those two sides. Angle or number 3 is going to have S between them, and triangle 4 is going to end up sharing G. We go from D to G, and we go from G to W, and then the angle included between those, like the hinge between those two sides, is the angle at G. Here we want to determine whether there's enough information for these congruent. So we got sides congruent, and then reflexive property lets us know that XY or WY and YW are congruent between the two triangles. So yes, they are going to be congruent because of side, side, side. And we also have to make sure the congruence is named the same way. Z to Y to W, or Z to W to Y, goes with X to Y to W. Next triangle, reflexive for AE, and that gives us ASS pattern, which doesn't work. If we could get that angle there at A to be congruent to the other one at A, we could use angle side angle, but I don't see a way of doing that. We can't do anything with the angle up there, angles up there at E, so I don't think there's enough information for this one. Looking at number 7, we can see that JK is the reflexive side shared between those two. So that gives us a third side. So by side, 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 those triangles are congruent. Let's make sure they're named the right way. K to H to J should go with K to L to J, and it doesn't. That's an incorrect statement. It should have been K to L to J. So JOK wouldn't have been congruent. Wouldn't have been correct. Here we can see that we have a side angle side pattern set up with what they've already got marked. So yes, those are congruent. D to A to K, T to S to K. If D to K to A, we go with T to K to S, which works. Looking at number 9, we got two right triangles, and if we get hypotenuse leg, that would be enough, and that does give us enough for hypotenuse leg. JM and ML are the hypotenuses, and KL and MK are the legs of the two triangles, and they're marked as congruent. So hypotenuse leg, yes. Let's look at this number 10. We got a side angle side pattern using the right triangle, or right angles there for the matching angles. So yes, that's congruent by side, 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 or side angle side. Also in some geometries, it's called leg, leg for hypotenuse. You see if hypotenuse leg, there's also leg, leg with right triangles. The same thing as SAS. Here we want to prove that these two triangles are congruent. We can see you've got vertical angles there at the center. So in the patterns, we can see that SAS is going to be what's going to prove this. All we have to do is get that information in. If we could do it in the correct order, like SAS spells it out, but we just have to go with what they already have given. With OB in the midpoint, that tells us that segment MO and segment QO or OQ are going to be congruent to each other. That gives us two sides congruent with each other. Looking at the next one, we're going to say that O is the midpoint of the other segment in P. So that means that ON and NP are going to be congruent to each other. That gives us another side. Third thing we have to do is get the vertical angles in there. MON is going to be congruent to OQOP, and that's the vertical angles are congruent. So we've set up side angle side pattern in the proof. We've established that. So we can say that the triangle is congruent by side angle side. Looking at number 12, we need to do a paragraph proof. So paragraph proof is like 3 or 4 sentences that kind of take the place of the 2-column proof. We still have to get the same arguments in there. So we might start out saying that we're given that AB and CD are congruent, and that BC and AD are congruent. And then by the reflexive property, we can see that CA is congruent to itself, which basically gives us that triangle ABC is going to be congruent to triangle CDA. So that's what we're going to write out pretty much as the proof. So we got the two sides. Now we got the vertical angles in there. Wait, it's not vertical angles though, it's reflexive property. So AC is reflexively congruent to itself. I'm naming it backwards because the other triangle is kind of named in the reverse order, but the same CA is the same as AC. AC is the same as CA. So since we have side angles, side, we can say that the two triangles are congruent. So there's our paragraph proof. In 2 or 3 sentences, we can kind of do the same thing we do in a 2-column proof. Let's look at number 13, which is our 2-column proof. We're told that AD and BC are congruent, and also they're marked as parallel. So that's going to let us set up vertical angles. From A to D to B is going to be a vertical angle with C to B to D. That's going to give us 2 angles. By reflexive, we're going to have BD congruent to BD. And that should give us side angle side then, with the 2 congruent angles. If we had that AB and CD were congruent, we could go the other way, but those actually are not marked as congruent, so that's a mistake. We can't really use those. We're actually using the other angles. So let's look. AD and CB, parallel lines. Inside angles there. The angle CBD is going to be congruent to the other angle, and that gives us the side angle side pattern. So to get the 2 steps in there, we've got AD congruent to BC. That gives us one of the sides. DB congruent to itself, reflexive. That gives us another one of the sides. We got to get parallel angles in the parallel lines in there, so we can use alternate interior angles. So AD parallel to CB is given. Now by alternate interior angles, we can say that those 2 angles are congruent, which gives us the SAS pattern. And we're pretty much done with the proof. So in step 5, we can say that triangle ABD is congruent to triangle CBD.